Wait.
Okay guys, today we're going to be doing lecture 33, acids and bases for worksheet. And today, on this worksheet, we're going to be doing number 16. Solid beryllium carbonate is placed in a solution of 0.5 molarity hydrofluoric acid. Now, let's look at this problem. Alright? Solid beryllium carbonate. It clearly states that beryllium carbonate is a solid. So, alright, let's start. Step 1, you write out the elements. Beryllium carbonate is a solid, remember it stated so. Plus hydrofluoric acid, and that's aqueous. Now, for step 2, we have to figure out what the products are. Alright. So basically we have to do a sort of replacement equation. I'm just going to rewrite the first part, the reactants. Now we do a replacement equation. So basically HCO3 H2CO3 plus beryllium. This is aqueous. This is a solid. Now both of these are solids according to solubility rules. Carbonates are not soluble. They're insoluble. Now what I did here was basically switch hydrogen with beryllium. So if you can see that, oh, good for you. Now for the third, now you see. Now you see, with this you have to use ions in order to know how to write these out. So I suggest you try to memorize the ions in order to do these problems correctly. Okay? Now for step 3, basically, you only separate the aqueous ones. Basically, you separate the aqueous solutions into their individual elements. Now, beryllium carbonate. You don't have to separate it because it's a solid. Now, so basically we have H plus F minus aqueous. Here's the next part. H2CO3 solid plus Be2 positive plus F minus. Now you can see I had to do this one by separating them into their individual elements according to their ions. Yes, I put out their ions. Now look at this. This top problem is not yet balanced, so we're going to have to balance this one. Alright, there's one beryllium, there's one carbonate. Now, hydrogen, there's 2 on this side, and there's 2 fluorine, so we're going to have to put a 2 in front of the hydrofluoric acid. Alright, our equation is balanced now. So now we have to change this to 2H plus, 2F minus. Okay, we're done with that step. Now the next last step, we basically just cancel any identical elements from both sides. Normally that would be the case, but as you can see, there isn't really anything to cancel. Now, let me explain. There's no BeCO3 on the other side. There's no H2CO3 on the other side, on both sides. There's no separate hydrogen on both sides. Now, the F's, the fluorines don't count because this is 2F. When I say identical, I mean identical. Exactly the same. So, these two elements cannot be cancelled. So basically, our last step, we just write out what our results are. Yeah, the equation didn't change at all because there wasn't anything to cancel. So this is your net ionic equation, guys. Recap. Basically, you put out the elements first that you mix together, and then you have to write them out based on ions in order to get to your products. Then you have to balance them. After you balance your equation, you basically have to separate the aqueous solutions into their individual ionic elements, as shown right here and right here. After that, you just look to see if you can find any identical elements from both sides to cancel. Since we couldn't find any, this is your final result. And that would be your net ionic equation. Thank you guys, I hope this was helpful.